go over again the pH calculations, how to do them. It's really all about the relationships among pH, hydrogen ion, hydrogen ion, hydroxide ion. Okay. First, the definition of molarity, which is a concentration unit, is moles per liter. When we see these brackets, that represents concentration, molar, molarity. Okay? Now, here are our definitions. First, kW. kW is actually equilibrium constant for water. Take that on faith. We'll be getting to equilibrium soon enough. But the kW we need for water at 25 degrees Celsius, by the way, is 1 times 10 to the negative 14th. Okay? pH, as you remember, is a definition. And by definition, what we mean is it's actually an invention. pH was Soren Sorensen, remember? French, puissance d'hydrogène, power of hydrogen ion. And the definition is negative log of the hydrogen ion concentration. Soren Sorensen had an epiphany that if he took the log of these tiny concentration units and changed the sign, he'd get a number, like 5. POH, okay, we don't use that very often. We usually use pH, but POH is the negative log of the hydroxide ion concentration. If you add pH and POH, the number is 14. Now, we can, just like if we want to get pH, we take the negative log of the hydrogen ion concentration. We can get the hydrogen ion concentration if we have pH. Let's say the pH is 5. You take the inverse log. Usually you hit shift or second log, and that's the inverse function for log. So you would take shift or second log, use the negative sign, not the subtraction operation, the negative sign for pH. So if you had pH of 5, you would do second log negative 5, enter, and what you get is going to be 1 times 10 to the negative 5th. You can do the same thing to obtain the hydroxide ion concentration. Okay? You do second log or shift log negative of the POH, enter, equal, etc., and you're going to get the hydroxide ion concentration. For example, let's say your POH is 7, okay? You do the second log or shift log negative 7, you're going to get 1 times 10 to the negative 7 for your hydroxide ion concentration. Okay, that's it.